everyone. In this video, we're going to derive the Pythagorean identities, or this is otherwise called the Pythagorean trigonometric identity. This is the identity expressing the Pythagorean theorem in terms of trigonometric function. In order that we can derive this Pythagorean identities, we are going to use the unit circle and the Pythagorean theorem. Let's have a review on the unit circle. So we remember that in a unit circle, the radius is 1. So if we are going to consider this point right here. So we're going to have this as point xy. So I will label this as xy right there. So we can draw a line connecting to that dot there. And remember that in a unit circle, the length of this line is 1, which represents the radius. Now we can drop a line down here, and this will give us the y value because that's vertical. So that's the y value, and on the horizontal line right here, this will give us the x value. So that's how we can get the coordinate xy right there. So whatever is the length of this y, that would be on this part of the coordinate. Whatever the length of this x, that's the x right there. So let's assume that this is angle theta. So we remember that the x represents the cosine of the angle, and then the y represents the sine. So that we can go ahead and say that this x represents, again, our cosine. So I'll just go ahead and write cosine theta. And then the y represents the sine theta, whatever that angle is. So I just assigned it with a variable theta. Now, what are we going to do next is we recall the formula for the Pythagorean theorem. So this is the formula for the Pythagorean theorem. Okay, so leg squared plus leg squared equals hypotenuse squared. Now we remember that this triangle right here is actually a right triangle. So this is a right angle right here, 90 degrees. So if we look at this triangle right here, our legs are x and y. So we can go ahead and write the legs would be x squared. That's the first leg. And then the other leg is y squared. And then the hypotenuse here is 1 because, again, this is the unit circle. Now, since we say that x is actually represents the cosine of the angle, and then the y represents the sine of the angle, so then we can go ahead and change this. Instead of writing x squared, we replace it with cosine. So the equation would come out cosine squared of theta plus sine squared of theta is equal to 1. And this is our first Pythagorean identity. So I'm just gonna put that inside a box right here. So this is the first Pythagorean identity. Now we derived the formula for tangent. So just by looking at this picture right here, we recall that the general formula for tangent of theta is equal to whatever that angle is. It's always gonna be opposite over adjacent. So that's why we have a TOA. So SOHCAHTOA. So remember the SOHCAHTOA? That's TOA stands for tangent is equal to opposite over adjacent. So looking at this triangle right here, our opposite to the theta, which is our angle, is y. So I can go ahead and write y over the adjacent is x. Now, again, we remember that the y represents the sine of the angle and the x represents the cosine of the angle. So then we can go ahead and say that the other formula for tangent would be, again, our y is sine. So I can go ahead and write this as sine of theta over the x is cosine of theta. So this is the other formula for tangent theta. So I'm just gonna put this inside a box. Now we're going to use this formula for tangent later on when we derive the other two Pythagorean identities. Again, so this is the first Pythagorean identity. Now we're deriving the formula for tangent here. Now, if we want the sine here in terms of tangent and cosine, we can go ahead and say that the formula for sine is Okay, so if we rearrange this original formula right here, we multiply cosine to both sides, so we can get rid of the cosine at the bottom to have sine left by itself on one side. So we can go ahead and say that sine theta is equal to tangent theta times cosine theta. Now, if we want the cosine, so we can go ahead and divide both sides by tangent theta so that we're left with cosine. So then the other formula of cosine in terms of tangent and sine would be okay, so again, we're going to use these three formulas for tangent, sine, and cosine in the second and third Pythagorean identity. Okay, so again, this is the first Pythagorean identity. That's cosine squared theta plus sine squared theta is equal to 1. Now, what are we going to do next is we will go over we're going to go through the second Pythagorean identity. So if we go back to the original equation that we got for the first Pythagorean identity, that is cosine squared theta plus sine squared theta is equal to 1. And again, we are going to use this Pythagorean identity right here. So we are going to change this cosine in terms of sine and tangent. So I can go ahead and use this formula right here. So I'm going to replace this. Cosine theta is equal to sine theta over tangent theta. But the thing is, this is cosine squared. So what we can do is just square this and square the tangent as well. Again, others are going to say, where did you get these three equations from? We had that in the first slide right here. So I just copied it. So what are we going to do now is we replace the cosine squared with this third equation that we got right here. So this becomes, so instead of cosine squared, we're going to replace this. So that is sine squared theta over tangent squared theta. This is actually equal to cosine squared theta. Again, you just put a squared to all of these, and that's how we got these equations. And then we get a plus sine squared theta equals 1. Now we are going to take the common factor for this. So as you can see, both of these two expressions have sine squared on them. So then we can go ahead and take the sine squared outside the parentheses since it's a common factor. So I go ahead and write sine squared of theta times. What are we going to do next is we are going to multiply this sine squared theta with 1 over tangent squared theta. So that if we multiply sine squared theta times 1 over tangent squared theta is actually sine squared theta over tangent squared theta. Now we are going to come up with the other expression right here, and that should be 1. Because if we distribute this sine squared with this expression right there, that would come out sine squared theta over tangent squared theta. Now, if we distribute the sine squared theta to 1, that comes out sine squared theta. And all of these will be equal to 1. So what are we going to do next is we divide both sides by sine squared of theta. So I'm going to divide this by sine squared of theta. And then I'll divide the other side of the equation with the same thing. That's going to be sine squared theta. So I can cross out the sine squared theta, sine squared theta. So the leftover here is going to be 1 over tangent squared theta plus 1 is equal to 1 over sine squared theta. Now we are going to use the other trigonometric identities. So I have here the other trigonometric identities that we are going to use in order that we can simplify this some more. So what are we going to do is, since we say that's 1 over tangent squared, we will look for that on this identities here. 1 over tangent squared is one of the reciprocal identities, which is actually cotangent. squared. So just put a squared on this and just put a squared on this. So this 1 over tangent squared is actually cotangent squared theta. And then plus 1 is equal to 1 over sine is actually cosecant. So then that's actually cosecant squared is equal to 1 over sine squared. So 1 over sine squared is equal to cosecant squared. So this is cosecant squared theta. So then this is the second Pythagorean identity. So we can rewrite this as 1 plus cotangent squared theta is equal to cosecant squared theta. This is the second Pythagorean identity. So I'm just going to put this inside a box. Okay, so what we did on the second identity was that we changed the cosine into its corresponding equation right here. So what are we going to do next is to determine or to derive the third Pythagorean identity, we are going to change this sine squared. So then we go ahead and I'm just going to go ahead and rewrite this one up here. Okay, so we go back to the tangent formula. So going back to these original 3 equations that we have here that we got from tangent, sine squared is actually this equation right here. So we can go ahead and rewrite this as cosine squared of theta plus this sine squared is equal to this. So that would be tangent squared theta times cosine squared theta. So I just multiplied these 2 together. So when we multiply these 2, it's going to come out sine squared of theta, and this is equal to 1. So then we can go ahead and factor out. The common factor here is cosine squared. So I factor out the cosine squared of theta, and then we use the distributive backwards. This should come out 1, because you have cosine squared of theta times 1 is cosine squared theta, plus this will be tangent squared theta. Because if we multiply cosine squared of theta times 1 is cosine squared theta. If we multiply cosine squared theta times tangent squared theta is tangent squared theta, cosine squared theta. And all of these will be equal to 1. Now, if we divide both sides by cosine squared theta, so I'm going to divide this by cosine squared theta. I'll divide this by, I divide both sides. So that would be cosine squared theta as well. We can cross out the cosine squared and cosine squared of theta. So we are left with 1 plus tangent squared theta is equal to 1 over cosine squared of theta. Now, going back to the other Pythagorean, trigonometric identity that we have here, 1 over cosine is actually secant. So we can go ahead and replace this 1 over cosine squared with secant squared. So the third equation would be 1 plus tangent squared theta is equal to secant squared of theta. So this is our third trigonometric identity. So pretty much these other 2 identities that we got on this slide are actually derived from the original or from the first trigonometric identity that we got from the first slide. That's it. If you find this video helpful, hit like and subscribe for more math videos. See ya!